Hello again. Did you think we were done with redox tables? Because I did. Apparently, the leading cause of death among humans is not knowing how to put elements in order of oxidation strength. So I guess we're practicing this some more. Let's go. You'll remember every time we get one of these, think of it like the more positive species looks at the other one and says, "I'm going to try to take some of their electrons." And what happens next is either there will be a reaction, meaning it succeeded, or there is no reaction, meaning it failed. And based on that, we're going to decide which of these substances is stronger or weaker than the other. So in this first case, the L ion tries to take electrons from K, and it does. Conclusion, L is stronger than K. Or on our redox table, L is listed higher than K. I'm going to regret putting that so high on the page. Let me fix that. L is higher than K. Okay. Next one, N tries to take electrons from K and can't do it. What does that mean? N is lower than K, weaker than K. Tried to steal from K and failed. Next one, K tries to take electrons from M, and it does. That tells us that K is higher than M, which is not fantastic because where do we put it? Does M go here? Does M go way at the bottom? All we know for sure is M is somewhere beneath K, so we're going to have to come back to this in a second. Hopefully one of the other reactions will tell us more. And last thing, M tries to take electrons from N, and how does that go? M succeeded because there was a reaction, so M is higher than N. That means this is not the case, and this one is. M goes in the middle there. In other words, M goes like that, and I'll lose these extra notes. So our ranked list is LKMN, and if we write that like a proper redox table, we'll get the L reaction. L2 plus 2 electrons is L metal, or whatever that is. K, it's going to be 2 Ks. The ions go on the left, then they gain 2 electrons and get reduced to that. This probably shouldn't have the 2's in it if I were making a really good redox table, but all I really care about is the orders, so we're probably okay. M, we have a +1 ion and then the metal version. M is something like sodium or lithium. And N, same thing. Single positive charge on the ion and neutral monatomic over here. So, strongest oxidizer, the L2 ion, strongest reducer, N metal. Can we do it again? Okay, manganese tries to take electrons from neptunium, and it does. Manganese must be higher than neptunium. Indium tries to take electrons from gallium, and it does. Now, this is a bit of a nightmare. I don't have indium or gallium on this list, so we're going to have 2 separate lists for the moment, and we'll find some way to glue them together shortly, I hope. This tells us, for now, we know indium is higher than gallium. And last thing here, manganese tries to take electrons from gallium and can't do it. So Mn is lower than Ga, which in turn is lower than In. So actually these lists go, shoot, I can't move it again. Ga and In like that. Indium is the grand champion, followed by gallium, manganese, neptunium. And if we do our redox table, the indium line will be In2 plus. Gallium would be +3. Bad alignment. I like all my arrows to be in a line. That looks spiffy, but didn't do a nice job this time. Manganese 2. picks up 2 electrons and becomes manganese metal. And neptunium is 3+. So it'll pick up 3 electrons on its way to being neptunium metal. So strongest oxidizer, the indium ion. Strongest reducer, neptunium metal. And one last one with made-up elements. This could be oxygen and this could be phosphorus, but M, this is the wrong structure for N, so that's probably not nitrogen, and there's no element M, so we'll just say these are all made up. M tries to take from N and succeeds. M is higher than N. O tries to take from N and fails. O is lower than N. And P tries to take from M and succeeds. P is higher than M. There's our ranked list. So, as a proper redox table, we have P3. Do you need to write the electrons when you're doing these questions? No, they aren't contributing anything. You've seen that in like 5 examples so far. So I'm writing these in to be a good boy, but if you just want to be efficient and write the positive ions and then the negative versions, go ahead. It'll work fine for these questions. M plus an electron turns into M. In the reaction, there were 2 of each of these, but I don't need the 2's for this to be true, so I'm going to leave them out just to show you that I can. N's, we have regular N turns into N negative 2. That's a bit unusual, but the more positive thing picks up 2 electrons, turns into the more negative thing. And O is like oxygen, only not. Gains 2 electrons and becomes that, I guess. It's hard to not write 2 and treat this like oxygen, but it's not oxygen. So, strongest oxidizer, the P ion, strongest reducer, whatever O is. Good. Hope that's the last of them. I'm kind of scared to turn the page now.